Will the release of the Realtime API actually replace platforms like VAPI, Retail, Blend, Synthflow? This is a question I previously answered in my video in a very short and concise way, and there were many questions about why I'm so bullish about this and not the opposite. So I decided to make this video and give you more insights of why I look at this the way I look at it, and to also give you a deeper understanding of what the voice orchestration layer actually is, how the Realtime API will affect it, the pros and cons of both of them, and why I believe it is actually a massive opportunity and boost for those platforms instead of a downside, and people having the fear of this new release of OpenAI replacing those platforms. Now, I'll try to not be too technical and give you a basic and plain understanding so that you get a basic understanding of what happens behind the scenes on those platforms. And to do that, I created an awesome Miro board that you see right now on the screen, so let's just head over there. And what you can see here is that I have a basic illustration of an AI voice orchestration layer. Obviously, this differs from platform to platform. Not every platform uses it the same way. That's why I also chose here as an AI voice platform VAPI, because we mainly work with that. It is incredibly powerful, awesome, and it is probably, I think, the most flexible approach to voice AI that we currently have, let's say that. And because I believe for this example, it is best as it has the most flexibility, so we can show off quite a bit more of those integrations that I believe are important for you to understand the whole concept. Now, let's just dive right in over here. As you can see, usually we have some kind of caller that calls with this voice platform, and the voice platform then is using some magic in the background, which is what we are seeing over here, to initiate a phone call with that user and give the user the imagination that he is talking to an actual human being, even though it is AI. And all of that is made by what you can see here in the orchestration layer. And you can see that we have a user input and we have an LLM output, right? So the LLM is basically the AI just outputting something that VAPI, or the AI voice platform, then uses to send the information back to the caller in form of an audio. So now you can imagine that when a user says something on the phone, let's for example say, I want to book an appointment tomorrow at 3 p.m. What happens then is that this information is sent to VAPI or to the AI voice platform. It then basically runs into the orchestration layer as a user input. So this is going to be audio. And now what happens is we need to translate that audio via speech to text to an actual text. And this is done by tools like DeepGram, Whisper, TalkScriber. And the reason for doing this is because as of now, there was no really good possibility of putting speech to speech, which is exactly why we had to go that extra step using text to translate or to convert what the user says. So that is compatible with the LLM layer, which you see down here, which is basically also referred to as the brain, because it basically handles all of the context, all of the reasoning, all of the decisions that happen within the LLM, and this is usually something that you create inside of your system prompt of those assistants to give a certain outcome that we can then basically just send back to the user in another format. All of this is done via these AI platform providers or these LLM providers, as you can see here. Obviously, the most common one is OpenAI, what we've worked with most, because it supports something called function calling or tool calling, which is incredibly important if you want to add utility to your voice assistant. Now you also have Perplexity AI, Anthropic, Grok. There are tons of different platforms around, and VAPI, for example, provides you the possibility of selecting them based on your needs. So you can even choose different ones for that whole orchestration layer to make this whole thing work. Now, let's for example say we send in some user input, we convert it to text, we send it to the LLM layer, the LLM now decides what to answer. So it will basically return as an answer. That's what you're also seeing with ChatGPT or with the OpenAI API in the first place. It gives back some kind of text, right? And that text is usually what you read and you interpret as the answer from the voice AI to do whatever you'd like with it. And in that case, what we do is we just don't manipulate it more. We literally use the text and we convert it to voice. And this is done again by another kind of provider, which we refer to as voice providers, which is for example 11 Labs. I just saw I wrote it wrong here. 11 Labs, Cartesia, and PlayHT. So all of those platforms basically provide the possibility of you sending in text and getting back audio. And not just audio itself, but an audio stream, meaning that we can actually make this whole thing work in real time. Now, once we have the audio, this goes back to the AI orchestration layer, which VAPI then basically sends back to the user as the audio, which kind of looks like there's a human talking, because that is kind of like what these platforms are built for in the first place, right? And this is already the whole magic behind it. So you can imagine that we send in user input as audio, which convert it to text. The AI does its magic, sends back some text, we translate that again to speech, and we send that back to the user so that he has the feeling he's talking with a human on the phone. Now, while this is already incredibly awesome and many people have used that to make more money, to remove manual work from their employees, make them happier as well, because obviously they don't need to talk to angry customers on the phone during rush hours or whenever it's like the busiest. And obviously also to use it for new use cases to for sales, for lead qualification, for appointment setting. Tons of really, really cool use cases. And this was already amazing. But obviously, since you can see all of those things that you see inside of this orchestration layer have to happen in real time or close to real time. So it feels like you're actually talking to a human. But as you can imagine, it still isn't that real time because there are a couple of problems in this whole orchestration layer that make it very, very hard for those companies to make it faster. And let's go to those kind of problems. So I've just listed a couple of them here. Obviously, those are not all, but those are very, very crucial ones that are incredibly important for making this a smooth experience, as well as for the ones that are actually calling on that agents, not just for the ones building, but also for the ones calling to have this really, really nice experience. So let's head over here. So the first one is obviously this whole thing is still comparably slow to human interactions. So you can imagine if you talk to a friend or another person, the answers are quite immediate and they are very, very tailored, both emotionally, empathetically, also with an accent to whatever they would like to hear or what they expect to hear. And this is a very smooth experience that happens in a couple of milliseconds. And now, because there are so many steps involved here, meaning that you obviously have to send that stuff first to a telephony provider that then sends the stuff to VAPI in that case, that then sends the stuff to the speech-to-text model, then sends it to the LLM layer, then sends it back to another text-to-speech provider, and then sends it back to VAPI, then to the phone agent, and then to the user. All of this has to happen in a very short amount of time. And even though it is a lot of steps, it already is incredibly fast. We're talking about around 1,000 milliseconds to maybe, let's say 1,500 or maybe 2,000 if you have a complex tool call and you don't handle the predefined message as well. As you can imagine, 2 seconds waiting time for an answer in the worst case is already bad. This is not really human-like, which again makes it just very slow compared to the actual human interactions. Now, this point is one that I believe is very, very important, and that is something that we have been struggling with the current system a lot, which is the loss of empathy, emotions, and accents. Because since we have this whole layer right here, let me actually just mark that so you see it a bit better. Basically, because this layer right here is basically what makes the loss of those kind of nuances like empathy and emotions. Because we cannot really put audio to audio, we need to go through text, convert that stuff. And as you can imagine, if you text to a friend on WhatsApp, on Telegram, whatever that looks like, you don't know exactly how the person means it in some cases, especially if it's sarcastic, because you cannot interpret the empathy or the emotions behind that message. So this is the same thing obviously with voice AI, because we cannot really connect any emotions to those messages anymore. We don't fully understand how we should interpret the input from the user, if he's angry, if he's positive, if he's happy, and then respond accordingly. Now, there are methods. There is something like emotional recognition, which is done on the speech-to-text level even, meaning that in the moment we get the audio, we can analyze based on the way the user writes or talks, whether or not he is in a certain mood, and we can use that within the LLM layer to make the AI understand that he is currently in that mood. So it's some semantic manipulations that we then do to basically get the right information back to the user. But this is the only possibilities that we kind of had until here. So this is a very big issue, right? Because we are removing emotions, empathy, the conversation always sounds a bit scripted and it doesn't sound natural, simply as that. Now, another problem as we see here is the reliability issues, because you see here we have tons of integrations that work together as one, meaning that if, for example, something like DeepGram is down or 11 Labs is down, this whole thing will break, obviously, because we have not integrated the other providers and one is down. So if we cannot send back audio, what are we going to send back? Basically nothing. So things run into problems and the user again has no smooth experience. So with having so many services involved, there needs to be tons of SLAs and the uptime needs to be really good to ensure we can actually make this whole thing work. Because even if one of those kind of providers has a delay in the answer, the whole thing will take a lot longer and will make the experience, again, not as smooth as it could be. Now, because there are so many providers involved, the next point also goes hand in hand, which is complex billing, because as you can imagine, as they are separate providers, every single one of them bills separately in most cases. Now, thanks to platforms like VAPI, they kind of handle most of that for you. So they combine everything into a single bill that you just pay at the end of the month based on the usage that you have. And all of those services are basically rebuilt through them so that you don't need to take care of this. Now, obviously, in case of VAPI, you can, for example, also use your own provider keys to make this work. But again, in general, people just try to avoid that because multiple billing things are getting a lot complex, especially to monitor, and obviously also for accounting and bookkeeping. So it's not a preferred way for many people to keep those things separate. And another point that I have here on the list, which a lot of people might ignore, is complex handling of voice interruptions. Now, you can imagine VAPI, in that case, must at some point decide when it believes that the user stopped saying something or when it starts saying something. Now, as of now, it is in the responsibility of the AI voice platform to decide whether or not a user stopped or started talking, and managing that properly is extremely hard. You can imagine there are tons of ways on how those providers make it work, and usually it works with punctuation. So when they basically translate that stuff to text, they can basically understand once there's like a punctuation set, let's say you have a dot at the end of the sentence, it is most likely that the user stopped saying something, so then they can send this message to the next step, which is then the LLM layer, and then basically stream the audio back to the user. Now, the same thing is about starting to talk. So you can set that as to many different variables, but a very common way is that you have it at, for example, 2 or 3 words, meaning that once 2 or 3 words have been translated or sent back by any of those speech-to-text providers, then VAPI would consider the user actually to start talking, which means it would cut the audio stream from the AI so that the AI stops talking, so that the user can continue without being interrupted by the AI, and the next answer goes into it. So again, it sounds a little bit more human-like. Now, because we need to take care of the start and stop talking handling, you can imagine that because we do it on text, it might be very hard to understand whether or not the user actually stopped talking. Because when you talk to an actual human, you know that there is like a switch in voice and tonality, etc. So it is very easy to recognize whether or not someone stopped talking or is continuing to talk. Now, because we translate stuff to text, it wasn't that easy as of now. And this is just like a minority of the problems, even though those are, in my opinion, the most important ones that we currently have or had, which is what brings us basically to the next point, which is the Realtime API. Now, for the Realtime API, I prepared another graph right over here that looks a bit different to what we previously had. But let's dive into the problems first, because you can see now that all of those problems that I just mentioned in the previous slide are now gone, thanks to the Realtime API, which is amazing. So even though the problems are gone, there are still some new problems, as you can see as well. But before diving into those, let's go over the actual example on how the Realtime API currently looks like from a very basic standpoint, so that you get an understanding of what the actual difference is to the voice AI or the voice orchestration layer we have seen so far. Now, again, we obviously have a caller that communicates with something, and here I'm saying a custom voice application because that is the current way on how I have tested it and how it is basically accessible for people that want to use the Realtime API. Now, I also have a note up here which mentions that it makes the setup harder because obviously, since right now it requires custom coding knowledge, you need to custom program it and have it on a server hosted so that you can use it. Obviously, this is just a matter of time until there are providers that start implementing the software and basically providing a more visual interface and a simplified version of you using their features to make things work. But that is a concern for later. What we have right here is the whole LLM layer, which is this part, which is the Realtime API. And as you can see, we now removed the equation of this whole text-to-speech and speech-to-text, which means we literally communicate directly with audio to the LLM layer and then with audio back. Now, we refer to that as speech-to-speech, so we literally just send an audio input to the LLM and the LLM immediately comes back with another audio input. Now, as you can imagine, this is incredibly powerful as it removes all of those issues that we had before. It is not as slow because we can cut out a lot of the API calls. We can cut out a lot of the needs for translating things to something because we can literally stream audio to audio. And the best part, we also don't have the issue anymore with the loss of empathy, emotions, and accents. Because now you can imagine we send in the audio, so the LLM is trained on understanding the audio, which again just helps it to nuance out what to answer because it can now kind of interpret emotions and the empathy and interpret that and give it back as an audio stream with the right approach and the right response to the custom voice application that can then send it back to the actual caller. Now, for me personally, this is one of my favorite parts, to have this whole empathy and emotions, because I believe it's going to make our applications a lot better. And as well, obviously, billing gets easier. There are less integrations involved because everything runs through a single API. So in that case, OpenAI is only billing you for the usage of that API and everything else is happening on the back end. And lastly, down here, the complex handling of voice interruptions is also gone because, as you can imagine, you don't need to make it understand anymore when to stop because it is kind of built into the Realtime API layer already. Now, this is incredibly awesome because you can now use the predefined SDK or code that OpenAI provides you and events to understand and schedule when to answer properly And all of this can be handled directly inside of the Realtime API, which is incredibly powerful. So it removes a lot of the needs for us to determining when a user stops talking or starts talking and when the AI should start responding again. Now, even though it is amazing, it is not completely without any additional problems, which is obviously the case with most of the softwares we build. There's always some downsides coming up as well to the positives that we are starting to introduce. And as I've mentioned down here, you can see I have 3 more points that I believe are incredibly important and are seen as new problems compared to the previous setups that we had with the voice orchestration layers. Obviously, the first one is limitations regarding custom voices. Because in the previous layer, you can see that we can integrate 11 labs, for example, which allows you to train a custom voice that you can then feed into the voice orchestration layer to answer on the phone with a certain voice, maybe even your own voice. I could, for example, create an AI voice assistant that has my voice and answers to the user in my voice. So it seems like I'm talking, which is incredibly powerful, as you can imagine, if I, for example, like to automate my appointment setting process, etc. Now, with the OpenAI Realtime API, as of now, you only have a couple of voices that you can work with. They are predefined, so you rely on them, and this is literally all you can work with. Now, I believe in the future, this will definitely change. You will be able to train your own voices. Just as of now, it is not there, and it is something that they need to be working on. Now, this kind of goes together with the next point as well, which is that it's harder to customize. Because obviously, since everything comes out of one API, we don't have the flexibility of adjusting things as we would usually have done that. And this, I believe, becomes also incredibly important if it comes to the right pronunciation of company or brand names, which was anyways an issue as well with a normal voice orchestration layer. Because you can imagine, not every company name is written in the way it's spoken. So sometimes you have company names that are spoken differently, which then need to be programmed into the orchestration layer. Now, 11 Labs has this awesome feature that actually allows you to use phonemes directly in the context so that it can pronounce a word based on the phonemes, which is obviously, as you can imagine, incredibly powerful as it overcomes the problem of pronunciation for brand names. Now, with us not having this possibility right here, obviously, again, it's a downside as of now, because we cannot adjust the pronunciation of some of the brand names. I believe it will also come, obviously, because it is a problem and it is nothing that is too hard to fix for OpenAI as well, I believe. So we will probably see a fix for that too. And now the last point, because we are early into that, it requires development experience. As I've mentioned up here, we need to currently write custom code to make it work just because it is so new. Now, with that out of the way, you should have a basic understanding of the difference between the OpenAI Realtime API and the actual voice orchestration layer. And the main difference is that we cut that whole speech to text and text to speech out of the equation, which removes latency, which removes more issues regarding reliability, and it also introduces extra things like empathy and emotions, which is really incredible. Now, because it removes so many problems of the voice orchestration layers we had before, I have seen so many times the question whether or not this is actually going to replace platforms like VAPI, like Blend, etc. And I've mentioned already previously, my answer is no, it will not. And I believe it's even going to be more beneficial to those platforms in the long term. And because I know you like to see data and you like to understand why I'm choosing an answer like that, I obviously prepared some more information for you right here that we are going to go over now, which I mentioned here, solution. And you can see now we have a bit of a bigger graph and we have cut out the application layer of that custom voice AI from the equation. And what we do here is that platforms like VAPI, for example, because I know VAPI is already working on something, we will basically see those platforms combining those two layers into their platform and basically just supercharging what they are currently already doing. Now imagine you can work, for example, with VAPI and you can choose by yourself inside of the dashboard or maybe in the backend whether or not you want to choose the voice orchestration layer or you want to work with a Realtime API. And this for me was already clear from the beginning because I saw the API, I saw the possibilities that allows platforms like VAPI or Blend to integrate those features into their existing platform. And not only that, that also means that they can share their existing tech stack in some way and the features and utility they provide. Now, simply imagine that when you talk now as a user with, for example, VAPI, in the backend, when you create those assistants, you will then be able to choose, for example, Realtime API as a separate setting that allows you to only use the Realtime API with predefined features that you can still customize in your ways to implement this Realtime API for your voice assistant in the backend without any custom coding knowledge directly through their platform. And obviously, same thing happens for billing and rebilling, which is amazing. Now, because of this, it eliminates a couple of things. Obviously, you don't need to know how to custom code anymore. Secondly, the barrier of entry is incredibly low because VAPI will handle most of the complexities that you would need to face if you would custom write those solutions. Another important point is that VAPI can, with their existing utilities, to make things a lot more powerful, which is obviously again in your benefit. And by providing those kind of layers directly inside of one platform, we're coming to my last slide down here, which just extends this whole thing a little bit more by just adding the whole utility stack on top of the features that they now just kind of combined. So imagine now VAPI, for example, providing you both the voice AI orchestration layer that we have seen as of now, as well as the real-time API layer, both of them already being integrated into the same platform, and then you having the possibility of leveraging what they already built and what they already figured out over the past couple of months, since they basically run as a company in the first place. You can use all of their knowledge, all of the features, all of the utility they built directly within their platform without you needing to write anything additionally to that. Now, as you can probably imagine, this is incredibly powerful, as it really saves you so much time by getting started by yourself. And to just get you an even better understanding of how that looks like, let's just head right over here to the utility section, because you can see that this introduces a couple of more features and benefits, which is obviously that you have an easy setup, a billing and maintenance, because these voice platform providers will handle all of that for you. So you don't need to take care of any new releases that the Realtime API brings, for example. All of that will be handled by the voice platform, which is incredibly cool. Secondly, you also don't need to have any custom coding knowledge. You will be able to do stuff with simple integrations with low-code or no-code tools like make.com, which again just like boosts the productivity. It allows you to just get an entry into this market without knowing how to custom code, which I believe is going to be very big as well in the long term, which again just a big benefit to those platforms. Then another very massive one is the simplified telephone integrations. Now imagine if we're going up here, for example, to the Realtime API itself, you would need to handle the integrations with Twilio. Now, if you've seen my previous video, I created a basic example that shows you how you can connect the Realtime API directly to Twilio. But obviously, if you're going to try that, you will face a lot of issues, like you need to program the first message parts yourself, you need to handle the function calling properly, you need to write tons of code just to make it work in the very basic version, which is something that these platform providers will handle completely for you. So you don't need to write any of those integration codes. You don't need to understand the Twilio markup language, which is another big one that you also would need to learn on top of it, because it's XML based and in my opinion a bit old school and outdated, which I just don't really like. But it is something you would need to learn if you would like to directly integrate Realtime API with Twilio, which again makes this whole thing a lot more complex. Now, another point that is incredibly important and really cool is the analytics, structured data and summaries. Because as you know, inside of VAPI, you can create custom summaries and analytics. You can get data, so basically KPIs, out of the call transcripts that are being created using their existing platform. And this will 100% also be available for the Realtime API, meaning that you have this whole analytics setup ready and you can use it to customize and get information out of those voice assistants or the Realtime API, which again, if you would write it custom, you would need to take care of that by yourself. Then obviously we also have simplified compliance, especially if it comes later down the line to HIPAA and maybe some other kind of regulations. This will also be handled by the platform provider, which is just another big time saver. And this is another really big one, which I believe in long term is becoming even more crucial and important, because even we in our agency, we see that working with squads is a lot better for reliability, cost savings, and obviously performance for the agents that we build for our enterprise clients. Now you can imagine this is extra utility that is added by VAPI that allows you, for example, to build whole teams of voice assistants, which they will also be able to leverage again using stuff like the Realtime API to build more powerful voice assistants with the utility they provide, so that you can literally do that either in the dashboard, or you even have the chance at all to build it on their predefined systems and predefined logic that they gave you access to within just their dashboard. Now this part really, I'm a big fan of that, because I believe this is going to be a massive boost as well for the functionality of the Realtime API, because that is probably something that OpenAI doesn't look into itself. Because as you can imagine, there are a lot more complex use cases that they need to face, and they obviously want to scale horizontally, not vertically, which again makes this thing a lot harder for them to implement special features like that. Then of course as well the simplified scalability, because they will handle hardware and everything like that. So meaning that if you run it on a custom server, you would need to take care of making this whole thing scalable, meaning if you get a massive amount of calls coming in, your server needs to be able to handle that. So the tech stack is completely yours and you need to manage all of this, which in that case with VAPI, they will handle this for you. And lastly, of course, two smaller points, which is organizational management. because obviously you can manage your organizations. It's again just some visual feature that is built into VAPI, for example, that you can just take advantage of without building this whole thing yourself. And lastly is the web SDK. So that is something that VAPI introduced so that you can use this whole voice orchestration layer on the website, which I believe will also going to be adjusted to support the Realtime API, because the Realtime API is incredibly powerful on websites as well. And we definitely see awesome applications. And by them basically implementing that into the web SDK, I am pretty certain that this is going to be really, really cool and powerful. Now, with all of those extra utilities, I'm pretty sure you should now understand that it is actually a massive benefit for those platforms to integrate their Realtime API into their existing structure instead of them being worried. So definitely get this out of your mind. I don't believe that the Realtime API will be the reason for many of those providers to get off the market or to kind of like fall down. Yes, there's always a case that it will happen to a couple of them, but the ones that are status flexible, such as VAPI, they will have the possibility of integrating this into an existing structure, just providing an even more optimized, better, faster experience for you to build voice AI agents. And with this, I really hope I made you understand that it is not as bad as you think, because obviously people are always getting afraid and thinking, oh yeah, there's something new coming out, it probably replaces this. Nope, in that case, it is more about the utility and the knowledge that they gathered over the past couple of months or maybe even years of working with voice AI in some way or the other. This utility is what you will have access to combined with the Realtime API, which is going to be incredibly cool. I'm really, really looking forward to this. And I know that VAPI is already working on something. I'm super excited to see that, and I believe we will see that as well in the next couple of weeks. Now, lastly, let's just go over the benefits that I wrote down over here, which is just again like some kind of confirmation and making it a bit more visual. So obviously you have the flexibility in choosing the right infrastructure. So imagine now you have both of those orchestration layers on the platform. And as you can imagine, not every customer will be fit for the Realtime API because they might want to have custom voices. You can then simply switch back to the orchestration layer and kind of make them intercompatible. So you can literally just go in and just try out what works best for that client and use that infrastructure for that client. So just because Realtime API is out yet, I don't believe it is completely replacing the voice orchestration layer as of now. And also I don't think it will do it in the near future. So it is still very viable knowing both of those platforms as of now, because the voice orchestration layer gives you still a lot of more benefits in some things that the Realtime API just doesn't. So having this flexibility on a single platform to switch between them is going to be incredibly powerful. Now, the simplified maintenance, obviously that was clear already from what I mentioned earlier. You will get access to all of those features, and VAPI will basically handle the complexities that go into building those voice AI agents on the backend side, making them compatible with all of those extra tools or external tools, so that it gives you a super smooth experience of working with the platform, as well as delivering exceptionally awesome solutions. This obviously also goes together with the seamless integration for the existing platform utility, as you will have access to the whole utility stack, or probably the majority of it. Obviously, it depends still a little bit on how exactly it can be implemented. Like there might be some parts technically that are harder to implement with the existing tech stack than others, but I believe that the majority of features will be compatible with the Realtime API of what we've seen so far. Now, another big one that will be probably really exciting for the majority of people watching me, which means that there's no coding knowledge required for understanding the Realtime API, because VAPI will do all of the complexities for you and you can use it directly from within their dashboard. And this one we kind of went over, but the last one, simplified feature releases. As you can imagine, it comes again down to maintenance. Let's, for example, say the Realtime API layer releases some new updates that you would like to use or leverage for your voice assistant. You would need to handle those updates by yourself, while in case you use a voice AI platform, they will basically do that for you. So they will implement the features, make sure they work with the whole utility, etc., so that you don't need to worry about it. Now, I cannot emphasize often enough that those voice platforms that are as flexible as VAPI, they will stick around. They will have the possibility of integrating this into their tech stack, making the platform and service offering even better so that you can build even more crazy and optimized voice assistants with it. I hope for now that really eliminated some of your doubts that I had with working with platforms like VAPI, because that was something we have really seen quite a lot inside of my agency for both the client side and as well from you as my YouTube subscribers, because the fear was real. There's something new coming out. You get scared whether or not this is actually going to replace something, because you obviously spent money and time on building something out that in the end becomes obsolete in the worst case, right? So you want to make sure that all of the things you do are tailored towards you being successful, which again still is the case with the voice AI orchestration layer that we've currently seen. But obviously with those platforms now, you can also leverage the Realtime API without you losing out on this whole investment. I'm still super bullish, as you can imagine, on this whole setup, and I'm looking forward what those platforms are brewing up. And you can be ensured that once there's something viable out, I will make sure to inform you about it, make a video about it, how you can implement it and leverage it for your company. So if you're interested in that, definitely subscribe to my channel. I would really appreciate it. And thanks for watching this video. I hope you really got some valuable information out of that. If you have any questions, you're most welcome to drop them below in the comments. I'm always reading them. And that's all I have for you now. Thank you very much for watching. I appreciate your time and see you next time.